Welcome friends. Now we are going to see in the non-fusion welding processes, that is soldering, brazing and braze welding. Okay, so before going into the process, now we should understand what is the need of using this soldering, brazing and braze welding techniques for joining of materials. So let us see the important needs to use these processes. So number one need is that whenever we are going to join the two materials, which are two different materials having the large difference in their melting point temperature. Okay, so what will happen if you go with the fusion welding? So for we are going melting for one, then at the same time the other may get evaporated because of the huge temperature difference between them. Okay, so this is one of the drawback of fusion in this case. If you take the second point, that is when you want to join a very thin part to a very thick plate or thick part to very thick part, you are going to just join a very thin part. So again in this case the fusion welding is not the suitable option. So you have to go for this soldering or brazing operation. And the third thing is that, so whenever you know that in the fusion welding techniques the heat affected zone is going to produce where there are certain metallurgical changes in the properties of the base material. But there are the engineering applications where we can't allow that heat affected zone get created during the welding. Okay, you are not at all give that tolerance to have the change in the properties of the base material. So in short, you are not interested or you don't want the heat affected zone into your weld. So in that case also the fusion welding is the not suitable option. So these needs lead us to get these non-fusion welding techniques, which are soldering, brazing and braze welding. Now let us take one by one. What is this soldering? Okay, so before going into details, I should clear here. So here the mechanism of this process, all soldering, brazing and braze welding, so they are having the same mechanics or mechanism in the process, that is the wetting and surface alloying. Wetting and surface alloying. So wetting and surface alloying means what? So if you are having these two parts to get joined by the soldering or brazing operation, so first of all the filler material, the third material here is the filler material, that you are going to put the filler material here in between. So this filler material, first what it will do, it will wet the joint, okay, and once it starts solidifying it will share the surface energy with the base materials, okay, and the joint is going to produce, and that joint we are saying is as the surface alloy. Okay, so this filler material is going into the joint, it will weight the entire joint, and during the solidification this filler material is going to form the surface alloy on with the base material. It will lead to the fixed joint, that is the surface alloying. So understood what is the mechanism of the all processes? Mechanism is very simple. Wetting and surface alloying, please remember this word, wetting and surface alloying. Now come to the soldering. What is soldering? So soldering is the process where the temperature in this process is less than 427 degrees centigrade, and which is also less than the melting point temperatures of base metals or parent materials. Base materials. Okay, where 427 is the evaporation temperature of tin. Okay, so if in the process the temperature is not exceeding 427 degrees centigrade, and which is again not exceeding the melting point temperature of the base materials, then it is known as soldering. Okay, now in soldering, please remember the filler material which are used, or very importantly the filler material in the soldering is called it as a solder. Okay, so in soldering operation we are using the very popular filler material, that is lead and tin. Lead and tin, this is very popular solder. We know this is eutectic mixture, lead and tin. So whenever you are using 50% lead and 50% tin in your filler material, that is in your solder, it is known as the soft solder. It is known as the soft solder. And you know that the application is very popular application of this soft solder in the electrical appliances. We are using this soldering operation. Okay, so where in that electrical appliances on in the electrical work, we use this lead plus tin solder, which is 50% tin and 50% lead is there in the composition. Now sometimes we are also adding here the bismuth, because what happened, what we can add here, bismuth. Sometimes bismuth is get added into this solder. As bismuth क्या करता है, it will reduce the temperature of the filler material so that the wettability is go on improving. Please remember bismuth किसके लिए use करते हैं, so it will decrease the melting point of the filler material, and ultimately what, it will increase the wettability. Understood? So bismuth is added. Now if you are having 30% lead plus 30% tin plus 40% silver. Okay, so this composition of solder will give us the hard solder. क्या बोलते हैं इसको, ये सॉफ्ट सोल्डर 50% tin 50% लीड था, इसमें क्या है 30% लीड 30% tin and 40% silver. It will gives you the hard solder. Okay, silver is having very good alloy forming tendency. Please remember, that's why silver is added, and it will improve the strength of the solder. That's why shear strength of the solder get improved. That is why the name of this solder is known as the hard solder. And this solder is basically used in the printed circuit boards in the space application, which are PCBs are used. In that we are using this hard solder. Okay, so this is about the soldering. Okay, now let us see what is brazing and braze welding. So again, in brazing and braze welding, the mechanism is same, that is wetting and surface alloying. Now here, see the filler material we are using as the copper plus tin, and we are also using copper plus zinc. So 60% copper, 40% tin we are generally using as a filler material, and the filler material here in the brazing operation is known as the spelter. फिलर मटेरियल को क्या बोलते हैं, फिलर मटेरियल is called it as spelter. Okay, and mechanism is same, wetting and surface alloying. Filler material known as spelter. Which filler material we are using generally, copper plus tin, 60% copper 40% tin. Also we can use the copper plus zinc. Okay, brass and bronze we can use as a spelter material. Now here, if you look at what is meant by brazing actually, so see here, so whenever you are doing this operation, this is the joint here, okay, and here is we are going to put the spelter. So in the operation, when you are not having any kind of joint preparation, so here simply the plates are kept in front of one another at the edges, and you are putting the filler material between the gap. This is simple square joint, isn't it? No any joint or edge preparation we have done. So whenever without any joint preparation you are using this technique of this brazing or braze welding actually, so this technique or this is the brazing only. This is the brazing where we are not going for any kind of joint preparation, say V joint, J joint, U joint. Simply you are placing the plates edge by edge and you are putting the filler rod material. This is the brazing operation. Okay, now so here number one I can write no any joint preparation, no any joint preparation. And second important thing is that, so here you can see the flow of molten metal into this gap. The gap is very small actually. Okay, how this flow of molten metal into the gap? It is by capillary action. It is by capillary action. Okay, so this is the brazing. Actually this is the brazing. Now what is mean by braze welding? What is mean by braze welding? So in braze welding, what is there? As there is a joint preparation, okay, as there is a joint preparation, the first thing is that there is joint preparation like V, J, U, single, double, right? And the flow of molten metal from the filler or flow of the filler material here into the joint, okay, is by gravity action. The flow of material, filler material rather I can say, filler material into the joint by gravity action, by gravity action. That's it. That is the thing only, nothing is very critical between the braze and braze welding. Okay, so simple. If joint preparation is not there, flow of this filler material into the joint is simply by capillary action. It is a brazing. And if you are having joint preparation, if the flow of molten metal is by gravity action, it is a braze welding. Okay, so if you look at the soldering and brazing, if you look at the heat sources for the soldering or brazing, so actually the soldering was very popular heat source for the air acetylene welding. Okay, but nowadays resistance heating is there for the soldering, and this brazing was a very popular heat source for the oxyhydrogen welding. Nowadays we are having brazing furnaces. Okay, so you keep the core which have assembled and put into the fluxes, deep into the fluxes, or pour the fluxes onto it and send to the furnaces. So it will go into each and every compartment. So whatever the process that are carried out for the getting that filler or flux into this joint, and at the one end you will get the product. The best example nowadays we can have the making of the condensers, heaters, radiators, which are used in the automobile industries. So they are all using the brazing, and they are using the brazing furnace. One of the typical trade name, the fluxes they are using in that is a Nocolock. Okay, so you can get that knowledge from these auto industries. So but this is very important application of brazing into the manufacturing of the condensers, heaters, radiators, etc. Okay, for example, heat exchangers you can directly say. Okay, now if you look at the applications of this brazing or braze welding, so see, this brazing and braze welding are basically used for the repairing of the cast iron pipes. Then whatever the cracks which are produced in the kitchen wells, that can also get repaired. Even you can use this brazing operation for the joining of the cast iron pipes also. Okay, then this brazing and braze welding you can use in the joining of the baffles to the manifolds in the boilers, in the condensers, radiators, heaters. Okay, so these are the applications of brazing and braze welding. Understood? So we have seen soldering, brazing and braze welding. Understood? Very simple thing. Now this strength of the braze joint, we are going to see how this strength of the braze joint is going to affect with the increasing distance between the two joining plates or gap between the two plates. See, these are two plates that we are going to join by the brazing operation, and here we are having our filler material. Okay, we have created the joint by the brazing operation here. Okay, now what happened when this gap is going to increase? This gap is going to increase. What is the effect of this increasing gap onto this joint, braze joint, that we are going to see? That is simply we are going to see the strength of braze joint, the strength of brazed joint with respect to the gap, between the two plates. Okay, what happened? So definitely, see, when this gap is very less, what will happen? So wetting or wettability is poor, so at that time the less strength you can get here. Okay, isn't it? Now when you are go on increasing the gap, what will happen? So the more material, filler material will come, then more surface get wetted, and there will be the ultimately maximum surface alloying. Okay, so as the gap you slowly go on increasing, so if you look at the strength, if this is the gap and this is the strength, if I put here, so the gap, as the gap goes on increasing, the strength is increasing, isn't it? And see, now after some time, definitely because of more wettability, more wetting of the surfaces and more surface alloying, you are having a very good joint. But now if you are again go on increasing the gap, what will happen? So you are applying definitely force here. Okay, so what happened? The entire load is now coming on to where? Onto the filler material. Okay, so now as you go on increasing the gap, now see, the load now is going to transfer on this joint, filler material, isn't it? This is our filler material. So again you go further increasing the gap, what will happen? Again the entire load is going to come on the filler rod, and now the joint is become weaker, isn't it? And at one moment, what happened? It will break or get fail. But from where? It will never fail where the sulfur surface alloying is happen or made with the base material. Okay, please remember, this braze joint never break where the surface alloying is done from the filler material with respect to base material. It is never break somewhere at the middle of the filler material or the joint is getting failed. So if you see here, as the gap goes on increasing, so it is strength is also goes on increasing, but after optimum gap the strength started again decreasing. So for some amount of, say, distance, you are having this uniform or equal strength or constant strength you are getting, but after that it is decreasing. So this is actually the optimum gap. Okay, from 25 micron to 75 micron you will get this constant strength, but after that what happened? The strength of the joint is goes on decreasing. So please remember, the thing is that the strength of the brazed joint is increasing with the gap, becomes constant for the optimum gap, and finally it will come down. Okay, so that is the thing you have to keep it in mind for the strength of the brazed joint versus the gap between the base plates. Okay, so this is the information about soldering, brazing and braze welding. Now see, we can also have the difference. You can put write down the difference between the soldering and brazing. Okay, so you can write here, in soldering the filler rod used as a solder, and in brazing the filler rod which is used called it as a spelter. Okay, so basically the soldering is the process having the applications which is where the strength is of the joint is quite low, but if you see the brazing operation, there is strength of the joint is of course higher than the strength of the solder or soldering. Okay, so this kind of differences again we can able to write for soldering and brazing operation. Continued. So students, let us fastly we will go through the as I said, differences between the soldering and brazing operation. So I have mentioned here these differences between soldering and brazing. So let us see one by one. We know already. First difference is of course of the definition. In soldering, temperature is less than 427 degrees centigrade, but again it is less than that melting point of the base materials. In brazing operation, please, I think ये मिस कर दिया था मैंने, प्लीज राइट द डेफिनेशन ऑफ ब्रेजिंग में क्या होता है, द टेम्परेचर ऑफ द प्रोसेस इज मोर देन 427 डिग्री सेंटीग्रेड, बट it is again less than the melting point of the base material. That is very important thing. Now here soldering, the filler material is solder, here filler material is spelter. Of course this is joint is having low strength, brazed joint having high strength, and solder is basically soldering used for the electrical applications, whereas the brazing is used for joining of similar or dissimilar metal pipes or fittings. Okay, so note this. Thank you.